Hey everybody. So we're getting into 5.1 today, representing functions as ordered pairs. All right. So I guess before I get into it, go ahead and get the title here, get this first slide, and we'll see what's going on. Okay. So I guess there's basically two parts to this lesson. The first part is going to be understanding what makes something a function. And then the second part is going to be kind of what the title is saying, representing functions as ordered pairs. Those are a lot of scary words. Don't be afraid. It's a pretty simple idea here. So yeah, first thing, it says a function is when each input has a single output. Okay, so a few things. We'll get into more what a function is, but basically you can think of a function as an equation that you plug things into and you get things out of. All right, it's kind of like your typical equation with an x and a y. You plug in a value for x, you get a value for y. Okay, your x value, there's a few names for it. The first name you'll see often is input. Okay, so your x values are your inputs, and then your y values are your outputs. All right. Another actually more common way you'll hear these words described is your x being the domain of your function and the y being the range of your function. Okay, so it sounds a little strange here, but the first thing we're going to understand is, when we have a list of ordered pairs, which by the way, this is an ordered pair. Remember, we were graphing those on the last lesson. Um, uh, when do we know that a bunch of ordered pairs are considered a function, and when are they not a function? That's going to be the first thing we get into. Okay, so on this first example, we're just going to get used to these words here. So go ahead and copy this. We'll do this together. All right, so this is saying identify the domain and the range of the relation. Another new word, relation. When you see a bunch of ordered pairs kind of listed with one another, usually they'll put these fancy little brackets on the sides. This is considered a relation right here. And they just want us to identify the domain and the range. Okay, so first, let's just write out domain, and let's list off what the domains are. The domain is just all of the x values to our ordered pairs in our relation. And you can see I've kind of color coded it to make it really obvious. So let's just go ahead and point it out. One thing normally when we list our numbers, we'll normally go from the smallest number to the biggest number. This is already in that order, but if it wasn't, we'd probably want to do that. Okay, so we know that our domain is a -1, a 0, 3, and an 8. Okay, easy enough. Our range, let's make it red, is just the y values of our relation here. And again, I want to put them in the order from smallest to biggest. So I'm going to actually start with this -2, and then +1, 4, and 9. Okay, so yeah, there it is. Domain, range, easy enough. That's what those words mean if they ever ask you that on a problem. All right, so on the next one here, they're going to ask us to determine whether the relation is a function. Does this represent a function? Okay, take a second, copy it. Okay, so real quick, let's go back to the definition of what a function is. Okay, it says a function is when each input, each x value has a single output, a single y value. Okay, so basically the idea is each of our unique x values needs to have just one y value. Okay, so for example, if we had an x value like 1, okay, and say our y value was a -2, if we had another 1 for our input, we could not have a different output. Okay, we could not have a different y value. If we did say it was -1, this right here would not be a function, because each input, our one input has more than a single output. It actually has two outputs. It has a -2 and a -1. Okay, that means it would not represent a function. Okay, so it's a weird idea, but that's what we're looking for. So on this problem here, this one's really simple, because if you notice, all of our inputs, our x values, are unique. We have a 3, a 6, a 9, a 12. Okay, so when it comes to the outputs, yeah, there's only a single output. When I have 3 as x, I only have one output as y. When I have 6 as x, I only have one output as y. So that's the idea on this one. We can say that, yes, this thing is a function. Okay, it'll make more sense when I show you when something isn't a function. So bear with me. This is kind of a weird idea to represent here. Okay, so let's try this one. Same directions. You don't need those again, but go ahead and copy this new relation. We'll figure out if it is a function or not. Okay, so I'm looking through this, and if you guys notice, I have an x value of 2 in both of these ordered pairs. Okay, and for this thing to be considered a function, that input would need only a single output. And if you guys notice, it does not have a single output. It actually has two different outputs. It has an output of 0 when I have a 2, and it has an output of -1 when I have a 2. Okay, and when this happens, that means we do not have a function. Okay, and I don't even worry about these because it's already ruined within these first two ordered pairs. Okay, but yeah, so that's the idea here. We'll say not a function. Okay, so kind of the easiest way to boil it down is when you get a relation like this, if you see any repeated x values, then you just need to see, okay, are the y values different? Okay, are they, and then normally they will be different, and then you'll say, okay, not a function, if the x values are repeated. Okay, so hopefully that makes sense. It's always kind of a weird thing for me to teach at least. So, but yeah, hopefully you're wrapping your brain around that. Okay, so from here, I'm gonna have you guys go ahead and try a couple of these problems. First thing, I want you to just identify the domain and the range. So on both of these, you'll do what we did on that first example. You'll say, okay, the domain are all of these numbers, the range are all of these other numbers. Okay, and then after that, I want you to determine if the relation is a function or not. Okay, go ahead and copy these down, give it a try. Okay, so first thing, let's get our domain. Remember, the domain is just all of our x values here. We're going to go from smallest to greatest. So I'm going to start with 5, 6, and 7. Okay, range is all the y values. Looks like I have multiple -5s. I do not need to write that twice. I don't need to go -5, -5. We just have -5 as a y value, and we have -6 as a y value. Okay, so here's the question. Is this thing considered a function? All right, well, here's how I'm going to break it down. I notice that all of my inputs, all of my x values are already unique. Okay, so that means I have only a single output for each input. Okay, 5 only has a -6 as its output. 6 only has a -5 as its output. 7 only has a -5 as its output. All right. Be careful to get it mixed around. Even though the y values repeat, that's okay, because it's all about whether 6 has a single output or multiple outputs, which makes this thing a function or not. Okay, so again, this is why we can say that, yes, it is a function. Yeah, I guess let's say yes, a function, just so we're clear on this. Okay, B, same idea. Let's go ahead and get the domain and the range figured out. Let's start with the domain. I'm going to start with the smallest number, so -3. All right, my next biggest number looks like I have multiple 2's. I only need to write it once. Okay, I don't need to write 2 and then 2 again. And then it looks like I have a 6. Okay, so there's my domains, my range. It's going to be all my y's. My smallest y looks like it's a 0. Next biggest, 2, 4, and then 5. Okay, so easy enough on that. Next question is this thing a function? Okay, well, here's what I notice. I notice I have repeated x values, repeated inputs. Okay, and that means 2 has an output of 0 as well as 5. All right, and again, for this thing to be considered a function, each input must have a single output. All right, and that is not happening on this problem. We have multiple outputs. We have multiple outputs for our input of 2. Okay, so that's why we're going to say no, not a function. Okay, so kind of a weird idea whether something's a function or not, but that's how it works. Just look to see if there's repeated inputs and make sure that number next to it is different, and then you'll say, oh, not a function. Okay, so let's keep moving. All right, so from here, we're going to look into using tables. All right, so go ahead, take a second and copy this. All right, so here is a table here, and basically this first column is going to represent the domains of our function, and the second column is going to represent the range, all of the y values of our function. When you guys go to draw these tables, you don't need fancy boxes like mine. Normally, I'll just do something like this, okay? And we'll say, this is my x values, this is my y values, and then you can just add some lines underneath it like that. So you don't necessarily need to make it super clean and nice, but I wanted a nice one for you. Okay, so that's a table. What can we do with it? All right, copy this example. I'll show you. Okay, so this says make a table of ordered pairs that represent the function. Okay, ordered pairs that represent the function. All right, so I'm first saying let's start by drawing ourselves a table. So I'm going to put it right here. Right, and left column will always be our x values, our inputs. Y value, the right column will always be our y values, our outputs. Okay, and another word to represent that is domain and range, which wouldn't be a bad idea. Let's go ahead and put that above this. Show that this is the domain, this is the range. The reason why is because if you notice, they're giving us the domain, the x values for our function. Okay, so let's go ahead and put that into our table here. So we know that we have 12, a 15, 22, and a 30. And I'm going to go ahead and separate these with some lines to keep it nice and orderly. Okay, so there's all our x values. Next, we just need to figure out what are all of our y values. Okay, well, to do that, here's where our function comes into to play. Here it is. All right. Normally, we just call this thing an equation, but I guess the technical fancy term for it would be a function. And the reason why it's considered a function is because we have an input and an output. We can plug numbers in for x, and we can get numbers out for y. All right. Here's one thing we always want to make sure of. We normally will make sure that this equation is solved for y. So when we plug numbers in for x, we'll get what y equals. Okay, and that's what we're going to do just now. So we're going to plug each of these one at a time into this equation. I'm just going to do kind of scratch work down here. So first one here, y equals, I'm plugging in 12 for x, so 12 minus 3. Okay, now actually I'm going to keep working to the right here. So I know that, no, let's work down. Okay, so I'm going to get y equals 12 minus 3, looks like I'm getting 9. Okay, so the idea is when my input is 12, my output, what I get, is 9. Okay, and let's just kind of keep moving along. This is kind of just scratch work here. You can maybe do this in your head, but just for the sake of some good notes, let's write it out. So next thing, I'm going to plug in 15 for x. I'm getting 15 minus 3. So it looks like when I plug in 15 for x, I am getting 12 for y. All right, next one here, 22 for x. So y equals, I'm plugging in 22, so I'm getting 22 minus 3. Right, so that means when I plug in 22 for x, I'm getting 19 for y. Okay, and last one, plugging in 30, y equals 30 minus 3. Okay, when I plug in 30 for x, it looks like I'm getting 27 for y. Okay, and there, we did what they asked. We made a table of ordered pairs, which, by the way, these are ordered pairs right here. Normally our ordered pairs are like this, 12, 9. Okay, but it's fine. We're just representing them slightly differently. But yeah, there's our ordered pairs, 12, 9, 15, 12, that represent this function. Okay, all right, let's try another one. Same directions, you don't need those, but go ahead and get this new one. Go ahead and get your new table. Alrighty, so it looks like our domains are given to us 0, 5, 7, 10. Let's put them on our graph, or our table, excuse me. Okay, and we're basically doing the same thing. So let's go ahead and plug those numbers in. So y equals 3 times x plus 4. Let's go ahead and start by plugging in our first x value, 0. Okay, when we do that, looks like 3 times 0 is 0. 0 plus 4 is 4. Okay, so when x is 0, y equals 4. Right. And yeah, let's keep moving along here. So y equals 3 times our x value on this next one is going to be a 5 plus 4. All right, so let's see, 15 plus 4 looks like we're getting y as 19 when x is 5. Okay, moving along, y equals 3 times x plus 4. All right, where our x value on this one is 7. So let's see, we're getting 21 plus 4, so we're getting 25. So when x is 7, y is 25. Okay, and last one, I'm out of room, I'm going to put it down here. Y equals 3 times x plus 4. X value is a 10. Okay, 3 times 10 is 30. 30 plus 4, 34. So when x is 10, y is 34. Okay. And again, we just made a table of a bunch of ordered pairs, 0, 4, 5, 19, that represent this function. Just by the way, they're not asking, but if we were to graph these points on a graph like we were doing before, we would get the line that represented this function. Okay. By the way, this is a linear function. We would get a straight line that represented this function here, but we'll get into that more in the future. I'm just trying to have you connect the dots in your head. Okay, so I'm gonna have you guys go ahead and try one of these. Again, you don't need the directions, but go ahead and write all of this out, get your domains, plug them in, and get all your ranges. Alrighty, so first thing, let's plug in our numbers. We have -3, I'm gonna make it black, sorry. -3, -1, 0, and 4. Okay, so there's all our x values. Let's go ahead and plug them into our function and see what we get for our y value. All right, so first thing, plug in -3. Okay, looks like we're getting 6 plus 1, 7. Be careful on this little math here. It's easy to kind of mess this stuff up. All right, so yeah, when x is -3, y is 7. Next one, y equals -2 times x plus 1. We're going to plug in -1 for x. Okay, so it looks like we're getting a 2 plus 1, 3. So when x is -1, y is 3. Next one, y equals -2 times x plus 1. We're going to plug in 0 for x. And it looks like we're getting 0 plus 1, 1. All right, and last thing is y equals -2 times x plus 1. Looks like we're going to plug in a 4 for x. Okay, so -8 plus 1 gives me -7. Okay, so double check your y values. Make sure you got what I got. It's easy to mess up this math. I'm going kind of quick, but go at a pace that works for you. Okay, but yeah, there it is. Again, a table that represents this function here. Eventually, we're going to get into graphing these tables, and you'll kind of see how this all kind of connects the dots. But this was mostly about learning how to make tables, understanding what a function is. So yeah, there it is, guys. I'll see you later. Bye.